All right, so let's try to finish the question in chapter 5. Okay. All right, the question is in page 371, question number 14. Okay, so the question is pretty long. So in one of the particle, this is called bactericidal property. Let's say how this material can kill bacteria. So of flat surface and nanoparticles derivatialized with alkylated polyisolamines. So this kind of materials, I don't know. Okay, so we have experiment will describe in which this is one type of materials. Okay, will attach to the surface and to nanoparticles to make them bactericidal, to kill bacteria. So in one series of experiments, the efficiency to kill bacteria against a certain bacteria was compared for this is methylated versus non-methylated polymer. So two types of materials. So one is methylated, the other one is non-methylated polymer. Okay. And the question tells us the mean percentage of bacterial cell killed in methylated polymer. So one of the materials is 95 with standard deviation of 1. And the mean for another materials is 70 with standard deviation of 6. Okay, and assume we have 5 independent measurements were made on each type of polymer. So the question is asked 95% confidence interval for the increase in bactericidal efficiency of the methylated polymer. So that is increase in these materials. So compare two sets of experiment. So when the sample size is small, in this case, we have 5 independent measurement. Okay, so when the sample size is small, n less than 30, and we want to know the difference between two mean values, so we use this set of equation. Okay, so mu x minus mu y is a function of sample mean for x minus sample mean for y plus minus this is the t value based on table 8.3. So v is degree of freedom, which is a function of Sx, Nx, Sy, and Ny. Okay. Half alpha, and this is also sample variance for x and sample size for x, sample variance for y and sample size for y. All right. So based on the equation for x, we have mean value of 95. Okay. Standard deviation Sx 1, sample size Nx is 5. For y, mean is 70, standard deviation 6, and sample size is also 5. Okay, so based on the equation for the degree of freedom, this equation, we calculate v value. Degree of freedom is around 4. Okay, so the t value is t4 based on 95 degree of confidence interval. Okay, half alpha is 0.025. Okay, so T4 0.025 based on table 8.3, we get the t value is 2.776. Okay, then plug in the number into this equation. Okay, so we calculate the range is 17.448 and 32.552. Okay, so again, this is small sample for difference between two means. In the previous example, we discussed large sample when n is large or equal to 30 for difference between two means. Okay. So the next question, question number 6, page 364, question number 10. All right, so in question number 10, we have article. All right, so evaluation of criteria for setting speed limit on gravel road. Okay, so counted the number of vehicles on various type on several roads in the state of Kansas. Okay, so in one county, 13 out of 67 vehicles on Washburn Road were heavy vehicles. On another county, 32 out of 91 on North 52nd Road Street were heavy vehicles. Okay, so asking 90% confidence interval for the difference between the percentage of heavy vehicles on the two roads. Okay, the percentage is the same as proportion, and the question is asking for the difference between the percentage of these two roads. So this is confidence interval for difference between two proportions, which is equation 5.18 on textbook page 361. Okay, and here shows the equation. So population proportion x px minus py is equal to sample proportion. Okay, plus minus the z value. Okay, this is also px modified px modified nx, and nx is a function of sample size nx plus 2, and this is the equation for modified px. Okay, the range for the difference between two proportions is from -1 to 1. Okay, cannot be smaller than -1 and cannot be more than 1. Okay, so based on this equation, for the first one, 32 out of 91. So the sample size is 91. So 32 of them. And nx, based on this equation, so nx plus 2 is 91 plus 2. For px, is 32 plus 1 over 91 plus 2, okay, based on that equation. So we calculate modified px. Same thing for y. So we have 13 out of 67. So ny is equal to 67. So modified y, n minus plus 2, 67 plus 2, modified py. So based on that equation, that's 13 plus 1 over 67 plus 2. Okay, and then we can plug in these numbers into this equation. For z half alpha, the question asks for 90% confidence interval, so half alpha is 0.05. Okay, based on table 8.2, z half alpha is 1.645. So the range is this. So that is question number 6. The next question, question number 7, is on page 375. Question number 9. And question number 10. Okay, so 9A and 10A and B. All right. So a tire manufacturer is interested in testing the fuel economy for two different tire tread patterns. Tires of each tread types are driven for 1,000 miles on each of 18 different cars. Okay, so shown in this table, we have car 1 to car 18, and for each car, we have two different tread A and tread B. Okay, and here shows MPG. Okay, so for each car, we have two different tread, and this is one pair of data. Okay, so the question is asking for 99% confidence interval for the mean difference in fuel economy. Okay, and because this is pair data, we should use the equation in section 5.7, which is showed here. Okay, the equation is on page 373, your textbook, equation number 5.24 and 5.25, depending on the sample size. Okay, so when the sample size is small, we use this equation. This is the mean difference plus minus the t-value. Okay, this is sample standard deviation. This is the sample size. When the sample size is large or equal to 30, we use the second set of equation. We use z-value. Again, this is sample standard deviation. This is sample size. Okay, so let's see for the first car, the difference is between 24.1 and 20.3. So the difference is 24.1 minus 20.3 is 3.8. Okay, so and we can calculate the difference for remaining 17 cars, and we can calculate the average of the difference. The average of the difference is 1.74444, and easily we can also calculate the standard deviation of the difference based on these values. It's 1.46. Sample size is 18. Okay, and because the sample size is 18 less than 30, we use this equation, the first equation. Okay, so the t-value, degree of freedom is n minus 1, which is 18 minus 1. Half alpha is 0.005 because this is 99% confidence interval. Okay, so based on table 8.3, the t-value is 2.898. Plug in this equation, we can calculate this 99% confidence interval. Okay, and then let's continue. So question number 10 said refer to question number 9. So in a separate experiment, okay, 18 cars were outfitted with tires with tread A, right? And another 18 cars. So this is different from question number 9. For question number 9, we have the same car. Car 1, we use tread A and then we use tread B. But in question number 10, we have 18 cars with type A tread and then another 18 cars with type B tread. Okay, so this is not paired data. Okay, so because this is not paired data, we should use small sample confidence interval for difference between two means. Okay, which we discussed in previous sections. Okay, small sample for confidence difference between two means. Okay, which is here. Use this set of equation. So for question number 10, we should not use pair data. Okay. All right. Okay, so then let's go to the last question. Last question is question number 8, page 384, question number 2. All right, here is question number 2. So in a sample of 20 boats, 20 boats, the average braking torque was 89.7 joule with a standard deviation of 8.2 G. And assume the braking torque are normally distributed. So A is asking 99% prediction interval for the braking torque, and B is asking for tolerance interval for the braking torque that include 95% of the boat with 99% confidence. Okay, so for prediction interval and tolerance interval, we only have one equation. Okay, This is different from confidence interval, which has many different scenarios. So for prediction interval, this is the equation 5.26 on textbook page 382. Okay, so prediction interval is equal to the mean value of x plus minus, this is t-value, this is the sample standard deviation, and n is the sample size. Okay, so let's look at the question A. Based on the question, sample mean is 89.7, standard deviation 8.2, sample size is 20. The t-value, so 20 minus 1 is the degree of freedom, and the 99% prediction interval, so half alpha is 0.005. Based on table 8.3, we get a t-value of 2.861. Okay, so plug in this prediction interval equation, we get a range for that. So that's part A. For tolerance interval, the equation is 5.29 number on page 384. The equation is here. Ti, the tolerance interval, is equal to mean value of x plus minus the k value. K has three parameters, n, alpha, and gamma. Okay, and to find out the k value, we need the table 8.4. Okay, so n is the sample size. So the sample size is 20, so the n value is 20. Okay, so for alpha, alpha is related to confidence interval. Okay, so 100 times 1 minus alpha is equal to 99. So alpha is equal to 0.01. Okay, for gamma, gamma means include 95% of the boats. So from there, gamma is equal to 0.05. Based on table 8.4, which is here. Okay, so table 8.4, degree of freedom is 20. 20 is here. For confidence level of 99% is here. And population content 95%. So the value for K is 3.1681. Okay, 3.1681. And plug in the equation of tolerance interval, we get the range 63.722 and 115.678. Okay, so that is the last question for chapter 5.